So this is going to be part 2 of section 5.2, and it's u-substitution with just a slight twist where the u-substitution doesn't work perfectly, and we're going to have to multiply or divide it or factor out something to get it to work perfectly. And let me just jump into the problem and you'll see what happens, and I'll just start doing the problem. I'm going to leave myself some room by doing the u work over to the side. So just like I would have done for the first 18 problems, for number 20, I'd go let u be equal x cubed minus 4. And then the derivative of u is 1, but I'm taking it with respect to x. So I'm going to get a du dx equals the derivative of x cubed is 3x squared. The derivative of minus 4 is 0. If I look at this and I start doing my substituting, easy enough. The x cubed minus 4 I can change to a u. The dx I can leave alone. Unfortunately, I have a 15x squared here and a 3x squared there. I need to substitute a 15x squared, and to make a 3x squared into a 15x squared, I have to multiply by 5, because my goal is to have this side as a 15x squared, but it's only because that's what I need to replace. I only have a 3x squared. I'm going to have to multiply. I'm going to say 5 times du dx equals 5 times 3x squared, and that's going to give me 5 du dx equals 15x squared. So now when I do my substitution for 15x squared, I'm going to put in 5 du dx. So the big difference between 19 and 36, I'm either going to have to multiply or divide to get the extra piece. It's not, the extra piece isn't going to come out perfectly. The rest of it's going to be more or less the same. Here the dx's cancel. I can rewrite this with the du last. It's going to be 5u to the 5th du. And now I'm going to add 1 to the exponent, divide by the new exponent. So I'm going to get 5u to the 6th over 6 plus c. I can change my u back to x cubed plus 4. And this is a perfectly fine answer. The alternative would be to make this 5 6 times x cubed minus 4 to the 6 plus c. Let me just check this, and I'll check this version. And how I check is I take the derivative of my answer. How do I take the derivative of this? So this is the checking part, and it's optional. I bring the 6 out front. I multiply it by the 5 6. I leave myself some room, and then I take the original parentheses, lower the exponent by 1. Where I left myself room, I wrote the derivative of what's inside the parentheses. The derivative of minus 4 is 0. The derivative of x cubed is 3x squared. The 6's are going to cancel. You're going to have 5 times 3x squared times x cubed minus 4 to the 5th. And then you multiply the 5 and the 3, and you get 15x squared times x cubed minus 4 to the 5th. And that's spot on what it needed to be, because that's always the derivative of my answer needs to be what's between the squiggly integral symbol and the dx. And I didn't emphasize, but the derivative of that c is 0. So in each of the problems between 19 and 20, when we find the du dx, it won't exactly be equal to the other piece. So we're either going to have to multiply or divide to get my du dx to be exactly the other piece. And so let's see if I can do that well here. actually teaching this a little bit different than I used to teach it, but I think it's better, but we'll find out if it is or isn't. So, 22. I'm going to let u be the inside of that parentheses. Then du dx equals to 8x plus 2 plus 0. Well, if I look at this and I look at this, they're not the same. It has to be the case that either I can multiply this entire thing by a number to get that, or divide this entire thing by a number to get that. And I look at the numbers. 8 and 32, 8 times 4 is 32. 2 and 8, 2 times 4 is 8. It must be the case that if I multiply both sides by 4, I should be able to make a perfect transition here. So I'm going to say that 4 times du dx, and now when I multiply this by 4, I go 4 times 8x is 32x, and 4 times 2 is plus 8. So when I substitute the 32x plus 8, I'm going to put 4 du dx. So for my substitution now, 32x plus 8 turns into 4 du dx. 4x squared plus 2x minus 7 turns into a u, and I leave the fifth power. And I still have the dx to cancel. So now I'm going to cancel my dx's. And I'm going to get the integral. I should have equal signs because this equals the line above it, but I don't always put those in when I probably should. So now I have the problem rewritten nicely. I can add 1 to the exponent, divide by the new exponent, add on the plus c. This fraction 4 over 6 reduces to 2/3. And I'd probably write this as 2/3 u to the 6 plus c rather than having the, I could have had 2 u to the 6 over 3 plus c. This version is better for me if I have to go check it with a derivative. I'm not done because I haven't changed the u to what it's equal to. I'm just going to change the u to what it's equal to, and I'll have an answer. So my answer is going to be 2/3 times 4x squared plus 2x minus 7 to the 6 plus c. So give 21 a go. So I'm going to give 24 a go. Of course, it has that ugly radical that I need to write as a fraction exponent. Cube roots turn into 1/3 powers. I need now to make the exponent negative because I don't want that fraction. Do my u work off to the side because it looks like it's getting long. So I'm going to let u equal the inside of the parentheses, the x cubed plus 4, then du dx is going to equal to 3x squared because the derivative of x cubed is 3x squared, the derivative of 4 is 0. Unfortunately, I want to replace a 24x squared. I have a 3x squared. I need to turn this 3 into a 24, and to turn a 3 into a 24 you multiply by 8 because 24 divided by 3 is 8. So I'm going to multiply both sides by 8, and when I do this I'm going to get 8 du dx equals 24x squared. So now I can rewrite this problem. In place of 24x squared, I'm going to put 8 du dx. In place of x cubed plus 4, I'm going to put a u. Now I'm going to cancel out my dx's. I'm going to get the integral of 8 u to the negative 1/3 du. Now I'm going to add 1 to the exponent. Negative 1/3 plus 3/3 is going to give me positive 2/3. So the exponent's going to turn to positive 2/3. There's already an 8 in front, and instead of dividing by 2/3, I'm going to multiply by 3/2. I tack on that plus c. Almost done. It turns out that I can cancel that 2 with that 8. I'll be left with a 3 times 4, which is a 12. And instead of writing u to the 2/3 power, I can change the u to an x cubed plus 4. And instead of having a fraction exponent, I can make a radical. So each of the problems in this bottom grouping, you're going to have to multiply to make your switch happen, or possibly divide. But it's only going to be by a number that you're multiplying or dividing by that doesn't have an x. So you should be able to give 23 a good go. Yeah. All right, so for 26, this needs a fraction exponent, which is going to be 1/3, and I'm going to move it up to the numerator and make it have a negative fraction exponent. So I'm doing it 2 things in one because we've done this a bunch of times already, just to save a minute. So cube roots turn into 1/3 powers. The cube root in the denominator, when you move it up to the numerator, gets a negative exponent. Wow. So I let u be 2x to the 4th plus 3x squared plus 5x plus 1. Now I take the derivative, du dx equals the derivative of this first piece is 8x cubed. The derivative of the second piece is 6x. The derivative of the third piece is plus 5. The derivative of the 1 is 0. I look at 8x cubed plus 6x plus 5. That's not exactly what's in that parentheses that I need to change out, but it's always going to be either multiplying everything by the same number or dividing everything by the same number. And here, I think if I multiply everything by 2, so I'm going to multiply everything by 2. And when you do that, I'm going to get exactly what I need. So I'm going to write 2 du dx, and that's going to equal to 16x cubed plus 12x plus 10. Now I can substitute that with 2 du dx, this with u. So I'm going to get the integral of 2 du dx times u to the negative 1/3. I didn't need that parentheses. It's okay to have it though. And then the dx is still there, but they cancel. Should have these equal signs, but I don't often write them. So this is going to be 2u to the negative 1/3 du. I'm going to add 3/3 to my exponent, and that's going to make the new exponent 2/3. And instead of dividing by 2/3, I'm going to multiply by 3/2. And that's the integral in terms of u. The 2's are going to cancel, and I'm going to get 3, instead of u to the 2/3, 3 times, oh gosh, 2x to the 4th plus 3x squared plus 5x plus 1 to the 2/3 plus c. The original problem was written with a radical. My answer should be written with a radical then. So this is going to be 3 times the cube root of 2x to the 4th plus 3x squared plus 5x plus 1 all squared plus c. That's my best answer. I probably wouldn't take points off on the test if you forgot to put a fraction, a radical, and left a fraction exponent, but I prefer it. So give 25 a go. A monstrously long section. So 28. 28 is an E problem, and in an E problem you always have to let u be the exponent of the e. That's the only thing I know how to do with e's. It's the only, every single e antiderivative, you let u equal the exponent. So du dx is going to equal 3. Right, this should be x squared. Du dx is going to be 3x squared, but I need to change out a 3/2 x squared. Well, I have the 3, I have the x squared, I don't have the 2 in the denominator, and the nicest way to get that 3/2, I could divide by 2. Dividing by 2 is the same as multiplying by 1/2, and what I'm going to do is I'm going to multiply by 1/2 on both sides. On the left side, I'm just going to leave this 1/2 du dx, and on the right side, 1/2 times 3 is 3/2, and I get 3/2 x squared. So because I had a 3x squared and I needed a 3/2 x squared, I had the 3 was divided by 2. I had to divide by 2, but dividing by 2 on this side would be a mess, and dividing by 2 is the same as multiplying by 1/2. So now I'm going to make my change outs. And for that right there, I'm going to write 1/2 du dx. So I'm going to say this is 1/2 du dx. And then for e to the x cubed, it's going to be e to the u. And then I have the dx that I'm going to cancel out. I'm going to write the du last. So this is the integral of 1/2 e to the u du. And the beautiful thing about e's is if you have a number times an e to a u, it is its own antiderivative. So the antiderivative, as long as the exponent of the e is just a single letter to a first power, it's its own antiderivative. So this is just going to be 1/2 e to the u plus c, and I need to change the u to x cubed. So for my answer, it's going to be 1/2 e to the x cubed plus c. All right, so give 27 a go. I'm wearing out. We've got a good amount of problems to do yet. This section goes up to 54, 56. Oh my Lord. Whoa. Whoa, 53, 54, 55, and 56. I'm going to cross those out right now. You're never going to see them. We're going to go up to 52. All right, so 29 and 30 are some more e problems. Always you let, in an e problem, let u be the exponent of the e. So I'm going to let u equal 2x cubed plus 4x squared plus 3, then du dx equals to 6x squared plus 8x plus 0. And then I ask myself, that doesn't look exactly like this. Do I have to multiply or divide to get this to look like this? I know that 6 times 8 is 48, 8 times 8 is 64. I think I just need to multiply everything by 8. So I'm going to multiply by 8, by 8, and by 8. And when I do that, I'm going to get 8 du dx equals 48 x squared plus 64x. So all of these problems, it has to be that there's one number I can multiply or divide by without a letter to get what I need to fix up. So for that junk there, I'm going to put in 8 du dx. For this exponent, I'm going to put a u. I'm going to leave the dx. Now I'm going to cancel the dx's. I'm going to rewrite this as the integral of 8 e to the u du. And that's the best kind of integral because that's itself as an integral. So that's 8 e to the u plus c. And then I just need to change the u to that. And my answer for this is going to be 8e to the 2x cubed plus 4x squared plus 3 plus c. A lot of times I forget the plus c's. I haven't been forgetting it so much today, I don't think, but it's common for me to forget the plus c. So give 29 a go. All right, 31 and 32. I need to rewrite both of these without the fraction with a negative exponent. I let u be the inside of the parentheses. Take the derivative with respect to x. I get 2, but I need a 14. How do I turn a 2 into a 14? Well, I have to multiply by something, and I'm going to multiply by 7. So this is going to give me 7 du dx equals 14. So for this 14, I'm going to put a 7 du dx, and for that 2x plus 5, I'm going to put a u. So I'm going to rewrite this as 7 du dx times u to the negative 3 dx. Cancel my dx's, and I get, this is the integral of 7 u to the negative 3 du. Add 1 to the exponent. Negative 3 plus 1 is negative 2. Divide by the new exponent. Tack on my plus c. I'm going to move the u down to the denominator to make its exponent positive. I'm going to move the negative up to the numerator because the denominator just has a monomial in it, and I don't like negatives in the denominators of fractions when I can get rid of them. So I don't know if that's readable, but that's a negative 7 over 2u squared plus c. And now I'm going to write my answer by changing the u to a 2x plus 5. So for my answer, it's going to be negative 7 over 2 times 2x plus 5 squared in the denominator. I'm going to leave it like that, plus c. All right, so I mean, these aren't that bad. It's just one extra step. The answers are maybe a little bit harder to get, but it's basically the same thing. In fact, these problems are basically the same problems. I've just took the problems that I wrote earlier and just changed a number to make them that little bit different. All right, so this was the problem that had the x squared that needed to be fixed, so I just fixed it. Again, so these problems, really, we've done the easier version of these problems. I'm just making them a little bit harder. All right, so this is 34. I'm going to write the problem with a fraction exponent. Square roots turn to 1/2 powers, and yours cube roots turn to 1/3 powers. I let u be the inside of that parenthesis, so I'm going to let u equal 5/2 x squared minus 3. I'm going to take the derivative of this, and when I take the derivative of this, I bring the 2 out front and multiply it by the 5/2. I lower the exponent by 1. 2 times 5/2 cancels out the 2. And I'm going to get du dx is 2 times 5/2. The 2's cancel, and I get a 5. I lower the exponent by 1 and get an x. And then the minus 3 has a derivative of 0. Unfortunately, I'm replacing a 5/4 times x. And how do I get a 5/4 times x? I either divide by 4 to get that 4 in the denominator, or multiply by 1/4. And on the left side, it's going to be easier to multiply by 1/4. So I'm going to multiply by 1/4 on both sides. And in order to do that, I'd have to think of the 5 as a 5/1. So on the left side, I'm going to get 1/4 times du dx. And on the right side, I'm going to get 5/4 x. And that's exactly what I was trying to replace. And so I'm going to do this off to the side here because I'm running out of room. So I'm going to rewrite this problem as, in place of the 5/4 x, I'm going to write 1/4 du dx. In place of the 5x squared, 5/2 x squared minus 3, I'm going to do a u. And then to the 1/2 dx. I'm going to cancel out the dx's. This is going to give me the integral of 1/4 u to the 1/2 du. I'm going to add 2/2 to the exponent, and my new exponent's going to be 3/2. And there's already a 1/4 in front of the u. Instead of dividing by 3/2, I'm going to multiply by 2/3. And I'm going to tack on the plus c. Don't have a lot of room here, so I'm going to try to do a couple things at once. I'm going to cancel the 2 and the 4, and that's going to turn me into a 6 in the denominator because I'm going to have a 3 times 2. The numerator is a couple of 1 times 1, so I'm going to get a 1/6. And now I'm going to do two things. I'm going to write this as a radical, so the 2 is going to be the denominator. Forgot the plus c. And under the parentheses, I would have a u cubed. But I'm going to change my u to 5/2 x squared minus 3. So since I've done enough of these, I'm trying to, because I'm short of room, I did a couple things at once here. So I wrote it in its radical form, a square root with an exponent of 3, and I changed the u to 5/2 x squared plus minus 3. The plus 3 I didn't have room for after the radical because it would go off my page, so it's just kind of hanging where it probably shouldn't hang. All right, so give 33 a go. All right. So, write it with a radical. So this is 36. So I'm going to write it without a radical with a fraction exponent. So I have a square root. Square roots turn to 1/2 powers. Let u be the inside of the parentheses with the ugly exponent. Take the derivative with respect to x. For this first one, I'm going to multiply the 4 by 1/4, lower the exponent to 3. 4 times 1/4 is just 1, so I'm going to get 1x cubed. Second piece, the derivative of 5x squared is 10x. Third piece, the derivative of minus 4x is minus 4. Last piece, the derivative of 3 is 0. I need to replace 2 times x cubed plus 20x minus 8. If I multiply everything by 2, I'll get that exactly. So I'm going to go through and multiply everything by 2. And the nice thing about that is going to make a perfect switch. So I'm going to get 2 du dx equals 2x cubed plus 20x minus 8. And now I can substitute. So for this parentheses, I'm going to put a 2 du dx. And for that parentheses, I'm going to put a u. And I'm going to leave this dx. Just like in every problem, the dx's are going to cancel. And now I have something that's easier to integrate. So this is going to be 2 u to the 1/2 du. I'm going to add 1 to the new exponent. And when you add 1 to the new exponent, that's 1/2 plus 2/2. You're going to get 3/2. So the u is going to have an exponent of 3/2. Instead of dividing by 3/2, I'm going to multiply by 2/3. So I get 2/3 times 2u to the 3/2 plus c. And then I'm going to do a couple things at once. I'm going to multiply these. And when you multiply those, you just multiply the 2, so that's going to give me a 4/3. I'm going to write the radical with my fraction exponent. So the 2 becomes the index. You don't have to write a 2 there. You can just write a radical sign without that number 2, and the 2 would be assumed. I'm going to create a parentheses with an exponent of 3 for the u cubed. That would normally be in the under the parentheses. And then in where the u was, I'm going to put that messy long thing if I can actually fit it in. So I need to write 1/4 x to the 4th plus 5x squared minus 4x plus 3. And that's a perfectly fine version of the answer, other than I really don't need the 2 written there. It would be a square root if I didn't write the 2 in the index spot. All right, so give 35 a go. All right, so we have one more group of problems, and I think I can do them all in this video part without making a part 3. And they're going to go from 37 to 52, which means I don't know what we have, like 8 problems to do or so. And each one of these problems, I say, involve a natural log. And we haven't done a natural log in a while. So the formulas that we have for natural logs really do need a -1 exponent. And I'm going to use, for this group of problems, this formula over and over again. And so let me try to show you how it's going to come up. So for problem 38, problem 38 doesn't have a parentheses with an exponent, but it has a fraction. And that fraction is certainly not my friend. I don't know how to integrate very well when we have fractions. So what I'm going to do is I'm going to rewrite the denominator with a parentheses and an exponent. Because any quantity, I can put a parentheses around anything with an exponent of 1, and it's going to equal to what it originally equaled, because x cubed plus 5 to the first power is x cubed plus 5 without a parentheses. But this allows me now to rewrite the problem without the fraction. I'm going to bring the denominator up to the numerator, just like we've been doing a lot in this section, and I changed the sign of the exponent from positive to negative. Well, now I have the perfect u substitution because I have a parentheses with an exponent, so you're going to let u be the inside of that parentheses. I just don't like the way this is written here. So I'm going to use this eventually here. So I'm going to let u equal x cubed plus 5. So du dx is going to equal 3x squared. And that's beautiful because I have that exactly. So now when I do my substitution, I'm going to go, this is the integral. In for 3x squared, I'm going to put du dx. In for x cubed plus 5, I'm going to put a u. I'm going to leave the dx. And just like every single problem in this grouping, the dx's cancel. And this gives me the integral of u to the -1 du. And that's what this formula allows me to do. Because basically, really it says the integral of x to the -1 dx equals the natural log of the absolute value of x plus c. In this formula here, it also allows you to have a number in front of the x or the u. Since I don't have a number in front of the x, when I integrate it, I'm not going to get a number in front of the natural log. So the integration of x to the -1 dx turns into a natural log, because you can't add 1 to the exponent and divide by the new exponent. If you added 1 to the exponent, -1 plus 1 is 0, and then you'd have to divide by 0, and so you can't use this rule. This rule doesn't work when n equals to -1, because then you get to divide by 0. So the integral of this is just going to be the natural log of the absolute value of u. plus c, and I just need to change the u out to x cubed plus 5. And so my answer for problem 38 is the natural log of the absolute value of x cubed plus 5 plus c. And so for each of the problems between 37 and 52, I'm just going to use the rule that says the integral, when you have a -1 exponent, turns into a natural log. If there's not a number in front of the term with the -1 exponent, then there's not a number in front of the natural log. If there's a number, a constant without a letter in front of the letter with the -1 exponent, it tags out in front of the natural log in your answer. So you should be able to do 37. When I go to do 40, I'll do it just like I did the last problem. I have to make the denominator have a parentheses with an exponent of 1 so I can move it up to the numerator. So in my rewrite of number 40, the original numerator I'm going to have to put in a parentheses. The denominator that didn't have an exponent of 1 that I turned into having an exponent of 1 will move up to the numerator. It'll get an exponent of -1, and we still have the dx. I didn't gauge that right. I'm going to let u be this. So let me just write that again just in case it's not clear. So this is 20x cubed plus 6x plus 2 times 5x fourth plus 3x squared plus 2x to the -1. Sorry that these bugs this summer have been horrendous in my office. It's been really not fun being in here because I've just been getting swarmed all summer. So I'm going to let u equal the contents of the parentheses with the exponent. Now I'm going to do my du dx. Du dx, the derivative of 5x to the fourth is 20x cubed. The derivative of 3x squared is 6x. The derivative of 2x is plus 2. So this whole thing is going to turn into a du dx. The parentheses is going to turn into a u, and we have a -1. I still have the dx there that I'm going to cancel. And this is the best kind of integral. The integral of u to the -1 du is just the natural log of the absolute value of u plus c. So when you have a -1 exponent, you get a natural log for your integral. And my answer now is going to be something without a u. I'm going to change the u to this 5x to the fourth plus 3x squared plus 2x. Leave that in the absolute value and keep the plus c. So these really aren't hardly any different. Oh, that surprised me. I looked at 42 and it just kind of surprised me. So I'm going to rewrite 42 just like I did. Any problem that has a fraction, and if the fraction's denominator doesn't have an exponent, you have to encapsulate the denominator in a parentheses and give it an exponent of 1. And now I can rewrite the problem so it's not a fraction by bringing the denominator up to the numerator, leaving the denominator in a parentheses. It started out with no exponent, so I inserted an exponent of 1, so when I bring it up from the denominator, its exponent turns negative. Now I'm going to let u be the inside of the parentheses with the exponent. I'm going to take the derivative of -2x to the derivative of 2x to the -3. I go -3 times -2 is -6. I lower the exponent by 1. -3 minus 1 is -4. The derivative of positive 5x is positive 5. And the derivative of -4 is 0. Again, this is a perfect substitution. So now I'm going to rewrite that piece right here as du dx. The inside of the parentheses as u. And I leave my dx, which I cancel. So this is the integral of u to the negative 1 du, which is the natural log of the absolute value of u plus c. And then for my answer, I change the u to what it's equal to. So for my answer, since the original problem had negative exponents, I'm going to leave those negative exponents in my answer. And I'm going to say the natural log of 2x to the negative 3 plus 5x minus 4 plus c is the integral, or the antiderivative, of my problem 42. So you should give 41 a go. Oh gosh, those don't work. 44 is no good. 46 is no good. Have to change a couple problems. Sorry, they had some problems that just don't work. They were just stupid. So we're even getting less problems to do, which is going to be fine. All right, so we just actually have 3 more problems to do, because I just had to erase a couple problems that were just, well, it didn't work, or they were dumb. So this is now 45 and 46, and for 45 and 46, again, we have the denominator that I need to give a parentheses with an exponent of 1. I need to rewrite the problem so it doesn't have a fraction by moving the denominator up to the numerator, flipping the sign of its exponent from a positive 1 to a negative 1. I let u be the inside of the parentheses. I take the derivative with respect to x. The derivative of this is 3x squared, but I need to change out a 12x squared, so I have to multiply. I'm going to multiply by 4, and I'm going to get 4 du dx equals 12x squared. So now I'm going to substitute in for this. I'm going to put 4 du dx. In for the inside of the parentheses, I'm going to put a u. I'm going to cancel the dx's. And this is going to give me the integral of 4u to the negative 1 du. And anytime you have an x to the negative 1 or a u to the negative 1, you get a natural log. And if there's a number preceding the negative 1 exponent term, that number precedes the natural log. So this is going to be 4 times the natural log of the absolute value of u plus c. And I'm going to change this to 4 times the natural log of the absolute value of x cubed plus 5 plus c. So it's nothing new in this section other than when you get a negative 1 exponent, you get a natural log. And that's almost easier than adding 1 to the exponent and dividing by the new exponent. All right, 2 more problems. I'm going to rewrite problem 48 as 10x cubed plus 3x plus 1 times 5x to the 4th plus 3x squared plus 2x to the negative 1 power dx. So I put the denominator in a parentheses, gave it an exponent of 1, moved it up to the numerator. Now I'm going to let u be the inside of the parentheses with the exponent. Now I'm going to take the derivative with respect to x. I'm going to get du dx equals 20x cubed plus 6x plus 2. I need to replace a 10x cubed, but I have a 20x cubed. I need to replace a 3x, but I have a 6x. I need to replace a 1, but I have a 2. I need to divide by 2, which is the same thing as multiplying by 1/2. So I'm going to multiply everything by 1/2. On the left side, I'm going to get a 1/2 du dx. On the right side, half of 20 is 10. So I'm going to get a 10x cubed. Half of 6 is 3, so I'm going to get a 3x. Half of 2 is 1, and I'll get a plus 1. So in for the 10x cubed plus 3x plus 1, I'm going to put a half du dx. So now I'm going to go 1/2 du dx. In for the parentheses, I'm going to put a u, and I still have the dx. I'm going to cancel my dx's. So this is going to be integral of 1/2 u to the negative 1 du. Negative 1 exponents are fun integrals because they just turn into natural logs. And I'm going to replace the u with what it needs to be replaced with, and I'll have my answer. So there really is nothing new in this bottom half. I think they're actually easier. We've done so many of these, maybe too many of these, but I just wanted you to get comfortable with them. And you change the u back to what it needs to be changed to. So last problem's coming up. All right, so now I'm going to rewrite problem 50 as the integral or antiderivative of negative 18x to the negative 4 plus 15 times 2x to the negative 3 plus 5x minus 4 to the negative 1 dx. Let u be the inside of that parentheses. So let u, that has the exponent of negative 1. So u is going to be it's going to be 2x to the negative 3 plus 5x minus 4. Take the derivative with respect to x. I'm going to get a negative 6x to the negative 4 plus 5. That's not exactly what I need, so I either need to multiply or divide by a number. 5 times 3 is 15. Negative 6 times 3 is negative 18. I'm going to multiply by negative 3. And it doesn't work. My original problem, let me just redo 50 on another sheet because it doesn't work the way it was written. No, I just multiply by positive 3. It does work. I'm just making a mistake because this is the last problem and I want to be done. I'm going to multiply everything by positive 3. So I'm going to go positive 3, positive 3, positive 3. On the left side, I'm going to get a 3 du dx. On the right side, 3 times negative 6 is negative 18. I leave the x to the negative 4. 3 times 5 is positive 15. That's exactly what I needed to replace. So this I'm going to change to a 3 du dx. The inside of the parentheses turns to a u. I'm going to cancel out the dx's like I did in every problem. I'm going to write this in a nice order as 3u to the negative 1 du. Negative 1 exponents, when they integrate, turn into natural logs. So that turns into 3 times the natural log of the absolute value of u plus c. I changed the u to this because the initial problem had a negative exponent. I don't mind leaving a negative exponent in my answer. Similarly, if the initial problem had a fraction exponent, I wouldn't mind leaving a fraction exponent in my answer.